So shell method is another way to find the volume. Are you with me, class? Another way to find the volume. Shell is like a cylinder. Okay, it's like a two-cylinder. Okay, so this is a cylinder. Just looking at this cylinder. Okay, so another method of finding a volume of a solid revolution is called the shell method because it uses cylindrical shells. Okay, so in other words, shell looks like this. That's a shell. Okay, do you see it? It's a cylinder, but you have a what? Little width. The width is very, very tiny width. Okay, yes, good. You have like a pipe. Think about the pipe. When you have like a plumber's pipe, you have an inside the diameter and then what? Outside of diameter. Do you see that? Can you imagine that? So think about this as a pipe, and you cut the pipe a little bit. Okay, then you will see inside where the water flows, right? And then the outer diameter will be what? A little bit bigger than what? Inside. Are you with me? So thinking about that. So shell is like a pipe. Plumber's pipe. You just cut it a little bit. Okay, not long, but just cut it. Cut it. So, but you can think each one of them like this. How do you find the volume of a cylinder? If you want to find the volume of a cylinder, what do? Because this part right here is a circle. So if I open this one up, what is my length here? What is my length? That is the same as what? Circumference of a circle. Is everybody with me? So in other words, when you open this one up, when you open up the cylinder, you will see looks like a rectangle in the middle part. This part right here, it looks like a long rectangle. Okay? And then when I say, okay, how do I find this, the bottom length? That's the same as what? Circumference of what? Circle on top or circle on the bottom. So what is your length over here? I'm going to say what? 2 pi r. 2 times pi times what? Radius. And then multiply by what? Height. So the area of this rectangle is equal to what? 2 times pi times r times what? Height. Can you see okay, guys? All right. Did everybody see it? The formula of a volume of a one cylinder, just any cylinder, you will see what? Oh, I forgot. Yeah. Area, circle times height. That is correct. I was talking the surface area. If you do surface area, I'm looking for area of a cylinder. So you what? Pi times circle times what? Height. That is correct. Yeah. So now consider a representative rectangle seen in the below. Sorry about this. It's not the writing is still too small. Okay, so this is what we're gonna do. Looking at this cylinder, this shell, this is the shell because it has outer and there's inner. There's 2 cylinders. Did everybody see it? The outer cylinder and then what? The inner cylinder. Okay, but I don't want to find both of them, so I want to find the average height. Okay, so we're gonna do some little calculation. So looking at this, this is what we're gonna use. We're gonna use right here. This is my width. And here is the radius. Okay, the radius, the smaller cylinder is called I'm gonna call it P, okay? P minus W over 2. Where's W? Width. It's the width right here. Okay? So I'm gonna use this width is a double loop. I'm gonna make it into half. Okay? So bottom half and top half. Because I want to find the average height, the average radius. So this inside, I'm going to call it P minus W over 2. What is outer one then? P plus W over 2. Are you see fast? I have a shell. I'm going to call it inside the radius, I'm going to call it this. The outside the radius, I'm going to call it what? That. Okay, I want to call it that way so I can simplify it. Okay, are you with me, class? Does everybody understand what's going on? So this is the height. Okay, just thinking of this is a tilt it back. Okay, tilt it up 90 degrees up. And this is your height. So inside the radius, I'm going to call it what? P minus W over 2. The outer radius will be what? P plus W over 2. Are you with me, class? Okay, using that, we're going to do some calculation. Look at the picture. Okay, so we have then the outer radius is P plus W2, inner radius is P minus W2. Now let's do some calculation. So the volume of a shell is volume of a larger cylinder minus what? Volume of what? Smaller cylinder. Plug it in there. We're going to do pi O squared times 8, right? That's the larger cylinder. What is this one? Smaller cylinder. Now let's plug it in what O is. O is what? P plus W over 2. Smaller one is what? P minus of W over 2. Okay. Now you got to FOIL this. FOIL that. If you FOIL this one, you get P squared plus PW plus 1W squared over 4. You have this one too. Okay. Now combine them. Let's combine them. When you combine them, since the pi and 8, the common factors, I'm going to leave it outside. But I will combine the middle one. Is everybody with me? So what can you say then? Remember, there's a minus sign. Because of that minus sign, what can you do? So everything, this will become the same as what? Negative pi, P squared, positive PW, negative W squared over 4. Does everybody see that? Right? Then can you see that you can cancel out what? That and that cancel out. And this and that cancel out. So what do you have? Simply what? 2 PW. Are you with me, class? Okay, now we're done. So we got the formula now. Now we have a formula that we're looking for. The formula is the formula for the finding a volume of a shell. A volume of a shell, what is that equal to? 2 times pi times, remember 2 times pi is 2 pi times what? The radius, the average radius times what? Height times what? Width. So that is the formula for the shell. If you want to find a volume, use your shell method, you use 2 pi what? P times what? H times W. Are you following me? Okay. Okay, so I'm going to explain to you. So P is what? Average radius. So we're going to either X or Y. Okay? And height would be what? The top function minus bottom function or what? Bottom function minus top function. Okay. What's the W? W is the thickness, which is what? The dy dx. Are you with me? Depends on what shape it is. Okay. All right. So you can think of like this. Okay. Does everybody realize something different about this problem? When you're rotating x-axis, this method, the shell method, when you're rotating around the x-axis, you are what? Evaluating in terms of what? Axis. But the shell method is opposite. When you're revolving around the x-axis, you're getting a dy because you're getting a vertical what? Do you see it? Let me draw a picture. Does everybody see it? You see this cylinder, right? So you drawing like this. This is your so let me make this a little bit lighter. The height. The height is the main thing. Okay, the height is what? I'm gonna draw thicker height. Does everybody see it? Height would be what? Right function minus what? Left function. Are you with me, class? Because of that, and you're gonna say, okay, my width is dy. Okay, and this function means it'll be what? Respect to what? Y. The radius is easy one. Radius is usually just what it is. You're gonna call yourself from here to x-axis to do this. So this will be just y. That's your radius. Okay, the radius is what? Simply y in this case. Okay, let's look at the problem together. So we do the problem, that will make sense to you if you do the problem together. So just like any other problem, depends which way you revolve or horizontal axis revolution. Just like the picture we just did it, you're evaluating everything with respect to what? Y. Are you with me, class? The shell method, when you're revolving around the x-axis, the variable is what? Respect to what? Y variable. When you vertically revolution like this, then you get what? Everything to be in terms of what? X. Okay, let's look at the problem. And the problem makes sense to you. The shell method is what? Height. The height will give you what variable to use. And if your height is like this, horizontal one, then what do you get? dy. Are you with me? If it's a vertical, what do you have? Yeah. Are you with me, class? Okay. Remember that, because it could have been confusing to you guys because you asked the disk method and shell method is exactly opposite. All right, so you have this problem. They find the value of the solid from the belonging division bounded by f of x equals x minus x to the third. And then between 0 to pi, all right, x is 0 to pi, and the y-axis is shown below. Okay, this picture is incorrect. Why? This is 0 to where? Pi. Oh, the pi, the y value would be what? So this is pi, right? But it's incorrect. The picture is incorrect. This should be pi. Okay, so that's incorrect. Not 1, it should be what? Pi, because we're going from where? 0 to pi. So this is a 0, 0. The other one should be what? When you plug it in pi, it'll be what? Pi minus pi, which give you what? 0. So this should be pi comma 0, not 1 comma 0. Everybody with me? My picture is incorrect. So I need to probably change that to 1 comma pi comma 0. We're not going anything below. Oh, you know what? You're saying my picture is wrong. It could be a 1 here. Okay. Let me see. That makes sense then. If that's a 1, then this picture makes sense. Okay. So now you're right. If I do pi minus pi to the third, which you get a negative number, right? Okay. So, so my boundary was wrong. It was 0 to 1, not the 0 to pi. All right. So this is what your picture looks like. Then we're rotating around here. So where's your other picture then? So we have, is it here? Okay, my picture should looks like that. Is everybody with me? Okay, so now let's draw our shell. Okay, is everybody with me? Then you're gonna say, okay, first thing first, let's just go and find it. So my radius Well, I call it P. That's equal to what? Simply what? X. What's the height? So you do what? Top minus what? Bottom.
X minus x to the third.
Let it be x minus x to the third minus what? 0, which is simply x minus x to the third. What's my width? I am doing it everything in terms of which one? Dx, right? I'm doing in terms of a dx. Remember, looking at the height. Height is what? Top minus bottom. That means what variable are you using? X's, right? If you do right minus left, what variable are you using? Y. Are you with me, class? So it's all x. So your width is what? Dx. All right, so everybody see this? And then you're going to say, okay, so what I need to do? Very first thing, what do you need to do? You need to recognize what I did. So what is the width? It's revolving around y-axis. So you know the width is what? Dx. Okay, what is P, the average radius? Since it is revolving around y-axis again, okay? Look at this picture. Where's your distance? All your distance is what? Depends on where you draw your cylinder. If I draw my cylinder, here, the smaller one, where's my average radius? It's whatever the x value. Okay, whatever the x values, that's my radius. Okay, so now, so that's that. Next one, what is the height of a shell? The height of a shell is what? We talked about that already. What's the height of a shell? Minus bottom, so which is what? X minus x to the third. Okay, now, how to find a volume of a single shell? What do you do? Put the formula 2 pi times radius times pi times what? We're going to do 2 pi times x, the radius, average radius. And the height would be x minus x to the third. And then when width is what dx, you simplify this and you get this. Now, what I'm looking for is what? I'm not looking for just the one single shell, but I'm looking for what? Every one of them. Do you see yourself? You do a smaller shell, and then a little bit bigger shell, and a little bit bigger shell, then what do? Trying to fill it up, okay? Fill it up the entire region. Okay, so now what do? You're gonna take the entire derivative. So you're gonna do between A to B. Okay, take the derivative over this. When you get 2 pi, this will be x to the third divided by 3. This will be what? X to the fifth divided by 6. You're doing between 0 to 1. So plug in as a 1, plug in as a 0, and you get a what? 4 pi over 15. That's what you have. Okay.
So the average radius x because it revolves around
y-axis. Right. So let me give you a second example so you can see. A second example where you will clearly see what the radius means. Okay. So I'm not gonna do any more. Then you get this. Okay. I did it numerically, so you can look at my numerically later. Okay. So I'm not gonna go over that because I want to go over example, second example.